You might not think about gravity much, but it affects everything we do. It's the reason why things fall down instead of flying up. It keeps us connected to the Earth, so we don't float away into space when we jump. But for physicists, gravity is something more. It's a fascinating puzzle that needs to be solved to understand how the universe works, and they're on a quest to uncover its secrets. So what's so mysterious about it? Let's see. We've learned a lot about gravity from the legendary Isaac Newton. He was the first to invent the law of gravitation. He taught us that any two objects in the universe can't help but be attracted to each other. It's like they have this secret gravitational crush going on. How strong this attraction is depends on two things: how big the objects are, that is their mass, and how close they are to each other. But here's where it gets cool. Gravity isn't just a two-object dance. It's a complex space choreography. Take our solar system, for example. The sun plays the lead role, using its gravitational pull to keep all the planets in their orbits. But each planet also has its own gravitational mojo, tugging at the sun and even its neighboring planets. Then, a few hundred years later, another hero, Albert Einstein, took gravity to a whole new level. He described the theory of general relativity. According to Einstein, gravity isn't just a regular force. In reality, it's curving and warping the fabric of space-time. Think of it as a heavyweight champion sitting on a rubber sheet. The sheet bends and curves under the weight, and the smaller objects nearby can't help but roll towards the heavyweight. Now, even though we can't see space's curves with our own eyes, we can see what happens to objects that get caught in its grasp. Getting pulled by gravity is like being caught in a whirlwind of forces. The caught object starts spiraling downward, just like a coin in those penny slot cyclone machines you find at tourist shops. Or it might move gracefully in circles, like bicycles racing around a velodrome track. Gravity is the primordial force that guides our entire world. Without it, there would be no stars, no galaxies, nothing. But where does it come from? Well, that's the million-dollar question. And we don't have a complete answer just yet. But we do have some guesses. First of all, we know that gravity is more than just a feature of space. It's a force that pulls things together. Surprisingly, it's the weakest force among them all. But let's take a different look at gravity. Something that may surprise you. Instead of being a force that directly pushes or pulls objects from a distance, it's more like a dance. Gravity, as amazing as it is, doesn't perform alone in this dance. It shares the spotlight with other forces, like electromagnetism, for example. Let's imagine two electrons. There are dancers. Now, they don't directly push or pull each other like you might expect. Instead, one electron creates a special kind of field around itself, like an invisible force field. This field sets the stage for the show. The other electron senses this field and starts to twirl and interact with it. It's like they're following some choreography. And when we watch this dance, it looks as if the second electron is being pushed or pulled by the first one. But in reality, it's all about the intricate movements and interplay between the dancers and the field they're dancing in. The dancers never touch each other directly, but their interactions through these fields make it seem like they're connected. It's a magical display of fields and movements coming together to create the illusion of forces at play. The thing we call gravity. So even though it's not a force in the usual way, it behaves like one. We call it an emergent force, because it emerges or comes out from the way space and objects interact. Which is why, if we want to get technical, some scientists prefer to avoid the words gravitational force and opt for the term interaction. It's just a way for particles to mingle and exchange energy and information. Electromagnetic interactions, gravitational interactions, they're all part of this grand soiree. At least that's one of the theories. Some scientists also think that gravity might be made up of tiny particles called gravitons. These sneaky particles work behind the scenes, making objects attract each other. However, we haven't been able to directly see these elusive gravitons yet. So, according to this theory, gravity is both a force and a potential particle. As you can see, we have some struggles with explaining how gravity works on a large scale. But at least we have a good understanding of how it behaves in certain situations, like how planets orbit the sun, or how objects fall to the ground and stuff. But what happens when we zoom into the atomic scale? And what if we venture into the depths of black holes and the Big Bang? Now here's where gravity's wild ride goes off the rails. First, let's enter the realm of quantum mechanics. There's something peculiar that happens in this tiny world. Gravity. The force that pulls things together seems to take a back seat. On a microscopic scale, other forces like electromagnetism take the spotlight and become the superstars. They're overshadowing gravity, and this leaves scientists scratching their heads, wondering, is this possible? Why does gravity suddenly fade away? So far, we have no idea. And when it comes to the grandest scales, where immense objects like black holes, gravity takes on a whole new level of complexity. For example, inside a black hole, laws of physics and gravity, as we know them, basically fall apart. It also decays when we try to understand how gravity behaved immediately after the Big Bang. Where did it even come from? We have no idea. In other words, we find ourselves in a cosmic fog when it comes to understanding gravity. But fear not, scientists are working hard to learn more about this enigmatic, emergent force. They're doing all sorts of experiments and using fancy technology to crack its code. Even though we still have a lot to figure out, we're making progress every day. For example, have you ever heard of gravitational lensing? It's like a mesmerizing magic trick. Imagine a beam of light as a fearless explorer, taking a straight path through the universe. But as it encounters the gravitational pull of a massive object, the light's journey becomes a wild roller coaster ride. The gravity of the massive object bends the fabric of space-time, creating a funhouse mirror effect. Our brave beam of light finds itself curving and twisting around the massive object, following a new, unexpected path. But as the light changes its trajectory, it also reveals to us distant and hidden wonders that would have remained invisible otherwise. The light can magnify, distort, or even create multiple images of faraway objects. So all the things that have been playing hide-and-seek with us finally become visible, like black holes. There's also a mind-blowing idea called gravitational waves. Einstein predicted their existence tens of years ago, but only recently have we finally been able to confirm them. And that was a huge breakthrough in the science world. These waves carry the echoes of cataclysmic cosmic events, such as the collision of massive black holes or the birth of newborn stars. Just like dropping a pebble into a serene pond, these crazy events cause a ripple effect. But instead of water, it's space-time itself that ripples and warps. Scientists have just recently developed a way to listen to these whispers. They've created instruments capable of detecting these gravitational waves. These instruments, known as interferometers, are like ears that are finely tuned to catch the subtle vibrations of the universe. But one thing's for sure. Gravity is a superstar that shapes our universe. It keeps everything around us connected and rules our entire universe. The quest to unveil its ultimate secrets continues, and it's a thrilling adventure for scientists and curious minds alike.
So, why haven't people built a colony on the moon yet? It's likely because they don't have enough building supplies. There are no hardware stores there. The only way out would be to deliver materials from Earth. Then, rockets would act as construction trucks. For comparison, imagine you want to build a house and use FedEx delivery to get all the necessary stuff. It would be extremely expensive and rather foolish. Using rockets would be the same. A colony on Mars sounds even more unrealistic right now. The distance from Earth to the Moon is about 239,000 miles, while it's at least 34 million miles between our planet and Mars. But asteroids are another story. They're rocky objects orbiting the Sun like planets, but they're much smaller, from 30 feet to 300 miles across. If you combine the mass of all asteroids in the solar system, it would still be less than that of the Moon. Those asteroids that do approach Earth carry trillions of dollars worth of metals and minerals, and some of them come so close that experts believe asteroid mining missions can become a reality in the near future. Your eyes shining, you switch off the TV. After getting to know such cool stuff, you find it hard to fall asleep. When you finally manage to catch some Z's, you dream of floating in endless space. You wake up with a start, feeling disoriented. Your body feels weird. You don't have enough oxygen to breathe. You open your eyes and look around. You're inside a sleeping capsule. Its walls are covered with tons of different buttons and tiny screens. After you experiment for a while, one of the sliding panels sweeps to the side. You crawl out of the pod. The absence of windows and any natural light makes you think you're underground. Dozens of sleeping capsules line the walls. The door leading out of the room is made of metal and looks heavy and unmovable. But once you press the button on the wall next to it, the door soundlessly opens. After climbing up a dark corridor for a while, you find yourself in a smaller room. Your heart sinks. There are at least half a dozen bulky spacesuits inside. What does it mean? Are you in space? Hey, good guess. You try to open the only other door in the room, which looks even sturdier than the previous one, but it just wouldn't budge. You sigh and start to pull on one of the spacesuits. As soon as you're securely packed inside, the door automatically unlocks. After waiting for a while in an airlock chamber, you finally make a step outside and the breath catches in your throat. As you look up, you see a beautiful blue orb. It seems to be glowing. Startled, you realize it's Earth and you're quite close to it. Are you standing on the moon's surface? Unlikely. This space body is way smaller, and its surface doesn't look like the surface of our planet's natural satellite. It has an irregular shape and is heavily cratered and pitted. Over your head, several miles above the surface, you spot a sizable boulder. Then, an asteroid. If so, then the rock suspended in the air is a companion moon. Judging from how close our planet is, it must be a near-Earth asteroid or maybe even an Earth crosser. Those are asteroids that cross our planet's orbit. Astronomers know about more than 10,000 of such space bodies. Almost 1,500 of them can be considered potentially hazardous to Earth. You feel proud of yourself for remembering so much info from yesterday's show. Suddenly, you realize that your spacesuit isn't attached to anything. And still, you aren't floating over the surface or slowly drifting away into open space. The asteroid must have artificial gravity. Otherwise, its own gravity would be too weak to prevent you from flying away. Come to think of it, creating a gravitational field makes sense. Without it, the colonists would have problems with coordination, balance, orientation in space. They would also constantly feel seasick. Blah. Plus, their bones will lose minerals and get 1% less dense each month. The next moment, the reason why you woke up deep underground dawns on you. The people living on this asteroid must have hollowed it out. Now, they're living inside. They also have made it rotate. The force that's created when a body rotates around its axis, called the centrifugal force, simulates Earth's gravity. Your suit provides necessary protection against cold and radiation. The temperature on the surface of an asteroid can be from -100 to -150 degrees. Without some heat source, you wouldn't survive for long. When you're on Earth, the planet's strong magnetic field and atmosphere protect you from solar flares and cosmic radiation. But asteroids don't have such a defense mechanism. It must be another reason why colonists live under the surface. Burrowing at least 300 feet deep inside the asteroid is enough to shield the colonists from radiation. Just then, a question pops up in your mind. What are you doing here? As if on cue, you notice a human-shaped figure appear nearby. From the way they gesture, you figure out they must be furious. Suddenly, your helmet radio switches on. Through the background noise, you hear, "What are you doing there? We don't have time to waste. Get down to work now." Work? What kind of work can it be? Oh, the colony must house asteroid miners. Astronomers think asteroids might be the material left after the solar system was formed, or they might be planetary debris. Planets often fall into pieces after getting in space accidents, for example, collisions with other celestial bodies. Even without visiting asteroids, scientists know what they're made of. They use a special technique. It helps to figure out what minerals or metals an asteroid consists of by analyzing the light reflected off its surface. Some asteroids might contain not only iron, magnesium, and nickel, but also oxygen, water, gold, and platinum. The asteroid you're standing on is likely to be one of those containing water. Without it, the colony wouldn't survive. Plus, the people working here likely break this water down into oxygen and hydrogen. That's how they produce fuel that makes all their machines and mechanisms work, and the oxygen is used for breathing. Let's say people mined all the asteroids in the asteroid belt between Jupiter and Mars. Then each person on Earth would get almost $100 billion. That's how much cool stuff these space bodies have. An asteroid with a diameter of less than a mile would weigh about 2 billion tons. This weight would include 30 million tons of nickel, more than 1 million tons of cobalt, and at least 7,500 tons of platinum. Such an amount of platinum alone would cost billions of dollars. And now, imagine how many asteroids like that travel across the solar system. Anyway, you can't procrastinate any longer. After all, you're here to do some mining. While you're shuffling in the direction where the angry man disappeared, you pay attention to the details. The machinery you spot looks to be solar-powered. There are lots of robots dashing around. You guess it allows the colonists to cut down on fuel, food, and other supplies. The mines on the asteroid are similar to those on Earth. The method colonists use to extract minerals is scraping them off the asteroid. Deep tunnels and shafts pierce the rock. By the way, those who created them had to be extremely cautious. Asteroids aren't giant boulders, they're rather loosely organized piles of rubble. If you aren't careful while drilling, these enormous heaps of gravel can just fall apart. They can also disintegrate when you spin them to generate gravity. That's why an asteroid must first be emptied out carefully. And then, the colonists have to make sure the spin doesn't cause too much stress to its structure. Speaking of artificial gravity, thanks to it, the miners don't have to worry about valuable ore floating off into space. Otherwise, a large canopy would have to be stretched over the mines and used to collect the precious stuff. After the asteroid's resources finish, the colony will be moved to the next asteroid. After a seemingly endless working day, you drag your exhausted body into your sleeping pod. The only question on your mind is it just a dream, or am I stuck on this asteroid for months to come?
You decide to go out for a morning jog for the first time in your life. You put on your headphones and get ready for something hard and unpleasant. But as soon as you go outside, you feel an extraordinary lightness. At first, you enjoy it and speed up, but then you realize that something's wrong. You're running too fast and too easily. You feel like you've just taken off a heavy backpack that you've been carrying all your life. You're so fast, you think you must have a superpower now. But you notice another athlete running as quickly as you. You notice a puddle ahead of you and jump over it. You jump so far and so high, it feels physically impossible. You fall to the ground, shocked. Then you notice there are no scratches on your body, and the ground feels lighter. You stop the music in your headphones and turn on the radio. All the news reports say the gravity on the entire planet has decreased by half. Thanks to gravity, we stand on the ground and don't fly away into the sky. This power allows our planet to revolve around the sun and the moon to revolve around us. Heavy things seem heavy because of gravity. And now, something has happened to the Earth's core, and the mass of our planet has decreased. This is the reason for the change in gravity. People happily run out of their houses and jump twice as high and further than they used to. Any objects seem twice as light to you. Your body has become lighter, so you can easily stand on your hands. But still, you don't feel like a superhero. You can't lift a car, even if its weight was reduced by half. But now, parkour is easier for everyone than before. Your body's weight has decreased, which means you get less damage when you fall. However, panic quickly replaces the joy of the new conditions. It becomes hard for you to breathe, the same as all other people. The air has become lighter. The updated force of gravity has reduced the air pressure by half. Now you feel like you're at an altitude of 16,500 feet among the streets of a usual town. It's like you're halfway to the top of Mount Everest. The air is no longer as dense, and the main part of it has settled in the atmosphere. In the beginning, everyone experiences massive dizziness and panic. You feel like there's not enough air in your lungs, so you get nervous. To solve this problem, you have to learn to breathe slowly and evenly. Thanks to this, you calm down a bit. Others also learn to be more balanced and don't live in a hurry anymore. All of you experience less stress and enjoy every day. Then scientists create unique oxygen masks. You put it on, take a breath, and a special filter puts pressure on the oxygen molecules, making the air denser. After a couple of decades, people will take off these masks as they'll ultimately get used to the new conditions. New generations will be born with adapted lungs. The Earth's atmosphere is expanding. It seems the sky has risen higher and acquired a darkish hue. Satellites flying around the Earth's orbit are now inside our atmosphere, but the Earth's gravity still attracts them. You see thousands of satellites burning up. Some of the space debris survives the atmospheric shield and falls to the ground. A meteor shower begins. Space trash crashes into houses, roads, trees, and cars. You and the rest of the people decide to wait out the storm underground, in the subway or basements. Fortunately, the shower doesn't last long. People come out of their hiding and look at the sky in surprise. The moon changes its previous position and slowly flies away. Soon it disappears completely. Our planet is now like a heavy ball in the center of a huge blanket. That blanket is gravity. It bends under the ball's weight. If you put any light object on the blanket, it will roll down to Earth. But if an object is moving at high speed, it will be able to spin on the blanket's edge and not fall into the center. Thanks to such speed, the moon doesn't fall on us, but at the same time, it can't fly away. Now that gravity has decreased, the blanket has become twice as loose. The rotation speed allows the moon to fly out of our gravitational field. It just goes into space. People will be able to observe the wandering moon for a long time through telescopes. Meteorites might crash into it. It could also find another planet with stronger gravity and will revolve around this new home. The moon may stay in place, but will be revolving around the Earth at a slower speed. In any case, there will be no more tides on our planet, and the sea level will remain the same. In the sea, you can also feel the changes. It's much easier for you to stay on the water, and you can swim faster. But the coolest thing is running along the shore. The splashes are floating in different directions, so slowly and beautifully. The waves are running on the sand in slow motion too. The weight of cars, planes, and ships has reduced, and so people consume less gas now. You can drive twice as far with a full tank. Fuel transportation is easier, and less energy is spent on flights. Gasoline is becoming cheaper. The decrease in gravity inspires space tourism development. It becomes much easier for people to fly out of the Earth's orbit. Winter has come. You're walking down the street during a snowfall. It seems to you the snowflakes are stuck in the air as they're so slow. You step on the ice and realize that it's almost impossible to walk on such a slippery surface. Your weight has decreased, and the pressure of your feet on the ice is twice as weak. You're sliding and can't stop. You often fall, but you don't feel any harm. When the wind is strong, it's hard to stay on your feet. If you jump, you may even fly away. The grip of wheels on the road deteriorates. A driver can no longer brake abruptly. The wheels don't spin, but the car continues to slide for a while. That's why new speed limits are being introduced all over the world. You can still enjoy extraordinary strength in long jumps, but after a few generations, the human body will evolve and fully adapt to these conditions. People and animals will be born taller and bulkier. Majestic tigers the size of a truck are walking through the city streets. Flamingos the size of a plane are flying in the dark blue sky. But the worst thing is that the size of insects has increased too. A regular cockroach can now grow to be the size of a computer mouse, and tarantulas become twice the size of an adult palm. At the same time, all living beings become lighter in weight. Humans will become elegant and agile creatures. Our bones and muscles will stretch. The structure of the entire human body will change. We'll become thinner and smoother. Blood in the veins and vessels will flow more slowly, and it will greatly impair the brain's work, but only in the beginning. In the future, the body will expand. The brain will increase, as will the number of neural connections inside. The lungs will become more sensitive and spacious. People will be smarter and wiser. All devices and materials will be developed according to the new conditions. A cup, a pencil, a plate, phones, and other gadgets. Everything will get lighter and more fragile. If an ordinary person gets into such a world, they'll feel like a superhero. You'll be able to punch through lightweight walls and doors and break bricks with your hand. New people won't match your power, but you'll seem too small and clumsy to them.
Okay, picture this. In the not-too-distant future, you're heading out on a space vacation, and you need to decide which items are worth bringing along. But instead of checking the weather forecast, you open a gravity simulator. That's because you need to know how each object will behave on different planets. For instance, should you take this metal shovel with you or not? Well, according to your itinerary, it's going to be a long trip. You're planning to visit every planet in the solar system and even a few moons. But due to the difference in gravity on these space bodies, you're not sure how useful some of the objects you're going to bring along will be. Well, let's start with the basics. Tupperware. I don't know about other space travelers, but us Earthlings carry our Tupperware around everywhere we go. And still, if you were to transport it to, let's say Mercury, it would most likely fly away into the atmosphere. These plastic containers you use to keep your food are too light. And since the gravity on Mercury is 2.5 times weaker as gravity on Earth, well, maybe you'll have to fill your plastic containers up before taking them out of your spaceship to have a picnic. If a Tupperware container weighs about 0.5 pound on Earth, it'll weigh just 1/4 of that on Mercury. Now, if we add some bananas, a handful of baby carrots, and 2 watermelons, then it'll be safe to carry it out of your space vehicle. You'll just have some difficulty making it all fit in a standard-sized container. But wait! Before you do that, you should know that the atmospheric temperature on Mercury can reach up to 800 degrees Fahrenheit. This means that any plastic container will instantly melt as soon as it gets in contact with the air. It'll burn up all the food, too. You can probably try taking a titanium container, that will work, or just stick to astronaut food. Now, shall we say Venus? Okay, Venus. If you were to take the same empty container to Venus, it would behave similarly to how it does on Earth. This is because Venus is also known as our planet's twin. These two have much in common. For example, almost the same size and mass. And when the topic is gravity, the formula goes like this. The bigger the mass and the greater the density, the stronger the gravity. Venus's gravity is approximately 10% weaker than Earth's. So, yes, you may leave your spaceship with your container, empty or full, and enjoy a beautiful and scenic lunch on the surface of Venus. Now, you'll have to figure out a way to eat without taking your spacesuit off, though. The atmosphere of Venus is filled with sulfuric acid, which can irritate your nose and throat and cause difficulties in breathing. Or worse. Much worse. Now, you'll have to forget about taking anything too light outside on Phobos. A little hint for you, it's not a Greek island, not even Greek yogurt, although it's a cool name. It's actually one of Mars's moons. Here, even your spacecraft would need a little extra help to keep close to the ground. If it weighed as much as a school bus, any regular-sized person could pick it up with just one hand. This is because on Phobos, the inhabitants of Earth barely feel the weight of gravity. And be very careful when jumping around because one leap and you may fly straight into outer space.
Passengers on board the Voyager spaceship, please keep your arms and legs inside the vehicle at all times.
Well, you're approaching Jupiter, a gas giant. A never-ending storm is raging in its atmosphere. Plus, there's no solid surface there, which means no landing for you on this planet. If you look out the window, it might seem that you are moving through a giant cloud. But for the purpose of your experiment, it'll work just fine. Try throwing into the air that baseball you brought along in case you get bored of all the space travel. And measure the time it'll take the ball to hit the surface. If on Earth, the ball will fall at a speed of 32,174 feet per second. On Jupiter, the same ball will hit the ground at a speed 2.5 times greater than that. That's because Jupiter is more than 10 times as large as Earth and around 300 times as heavy as our blue planet. Now, if you move your spaceship just a little bit to the side, to one of Jupiter's moons, Europa, the situation will be completely different. Throwing a baseball in the air on Europa will mean never seeing it again. Gravity there is almost non-existent, which means that not only a baseball, but even a grown-up person can fly away any second. Now, on the other hand, if you decided to venture out of the spacecraft to explore Europa's gravitational field, why not try to lift the space vehicle itself? On Europa, a regular Earthling can easily lift up to 1,000 pounds, which is the equivalent of a full-size male moose. Or you can lift a pyramid-like formation of 9 regular people. The choice is yours. When approaching Saturn, be careful. While from afar, Saturn's rings look smooth and solid. From up close, you'll notice that they're made of chunks of ice and rocks floating in space. You won't want to have your spacecraft anywhere near those. There's also no solid surface on Saturn, which makes landing impossible. And the atmosphere is full of ammonia. Keep in mind that it's a pretty inhospitable environment for a human. Now, inside the spaceship, you find a collection of sci-fi books, enough to fill an entire bookshelf. Altogether, they must weigh around 400 pounds. Yep, that many books. And like someone with a superpower, you try to lift over 200 pounds of weight at a time. But guess what? You fail, because Saturn's gravity is too similar to that on Earth. Now, in case you got confused with all this gravity talk, when we're measuring gravity, we're speaking about the power of the force by which a planet or other space body pulls objects toward its center. So, if you need some help in organizing that sci-fi collection in alphabetical order, ask the crew to move the spaceship to a neighboring space body with a weaker gravitational pull, like Pluto. These days, it's not considered a planet anymore, just a dwarf planet and one of the furthest from the sun's space bodies. You'll need an extra warm spacesuit to wear there. Pluto is freezing cold and has a tiny surface. It's smaller than Earth's moon. But it's a great place to test your strength. If on Earth it's kind of impossible for a regular person to lift an elephant, on Pluto you'll be able to pick up a baby elephant weighing around 265 pounds. Or even a medium-sized elephant that can be as heavy as 2,000 pounds. On your way back to Earth, you make a pit stop on Uranus. The coldest planet in our solar system has an average temperature of around minus 350 degrees Fahrenheit. So, if you attempt to get out of the spacecraft, you'll freeze mid-movement. Although gravity on Uranus is pretty similar to that on Earth, there's one thing that's very different: time. A 2-week getaway on Earth turns into a 3-year-long vacation on Uranus. Now, when you get sick of cold planets, you can travel back to warmer ones. Okay, now, Mars is definitely warmer than Uranus, but its average temperature is still about minus 81 degrees. On Earth, we only have such low temperatures at the South Pole during the winter. When you land on Mars, you'll start to feel light and strong at the same time. Mars's gravity is about 2.5 times weaker than that on Earth. So in other words, you'll probably manage to lift your own body weight without any difficulty. So all those handstands you've been dreaming of doing, you've found the place to fulfill your dream. Oh, gravity, you heartless so-and-so. Well, that's what I think when I trip over a stone and fall face down. Of course, I'm not clumsy, you know. Anyway, gravity is a constant, right? Something entirely unshakable that we can always rely on in this ever-changing world. Unlike, love. Feeling romantic, sorry. But what if I told you that it's not as honest and clear as you think? There are places on our planet where gravity behaves like it's gone crazy. And that's why you clicked here. So let's take a look. Magnetic Hill in Leh, India. There's a stretch of road in India that's been attracting tourists from all over the world. It's no different looking from the surrounding landscape, and you could easily pass it by without noticing, if not for one very unusual and a bit creepy thing. If you stop your car on the magnetic hill going up the slope and put it on neutral, it'll start crawling upwards, eventually reaching the speed of up to 12 miles per hour. They say there's some sort of magnetic force at work here that tugs cars up the hill, hence the name. On top of that, even airplanes are said to gain altitude above this place. Skeptics offer another explanation, though. It's just the lay of the land that creates an illusion of going upwards, while in fact you're moving down the hill and vice versa. Whatever the truth, I'd like to see it for myself. Would you? Tell me down in the comments. The Crooked Forest, Poland. Near the village of Nowa Charnowo, there's a forest in the depth of which you can find a strangely looking pine tree. Planted in the 1930s, there are 400 trees that sharply twist to the north almost at the roots, and then grow upwards in a semicircle. Although scientists offer different theories about the tree's weird growth, nobody can say for sure what made them look like that. Some say it's people who did it, while others believe it's a gravitational anomaly that somehow pushed the trees down. The trouble with this version, though, is that it would have had to stay there for years, and that only affected the trees. Still, no certain explanation exists anyways, so who knows? A waterfall, Faroe Islands. Ever seen an upward-moving waterfall? You can have a look at one on the Faroe Islands, halfway from Iceland to Scotland. But if you were expecting me to tell you an unbelievable story about a mysterious force pushing the water up the rock, then sorry, no such thing here. The truth, however, is quite jaw-dropping anyway. The winds in this place are so powerful that they lift the water and throw it back up. I guess it was this kind of wind that allowed Mary Poppins to travel on her umbrella. Sounds good. In fact, this waterfall is not unique. There are several more places on Earth where winds create an illusion of defied gravity. For example, there's the Kinder River in England that has a waterfall constantly struggling with the wind. It's so strong that half of the Cascades water seems to just fly up without ever touching the bottom of the drop. Hoover Dam in Nevada, USA. If you ever get up to the top of the dam, which is about 726 feet high, you can try a little trick. Take a bottle of water and pour it over the edge. You'll see the water flow up instead of spilling down. Once again, this isn't really any magic or unnatural phenomenon. The wind up here is simply too strong for the water to fall, just like with the waterfall on the Faroe Islands. Here, though, it looks even more impressive since you can do it yourself. Dokkaebi Road, South Korea. Another gravitational anomaly located on a road. Locals once found out that if you put an empty can or a bottle on the ground, it will immediately start rolling uphill. Unlike other such places in the world, though, Dokkaebi Road doesn't just create an illusion. When you walk down the slope, you don't feel as if you're going up. Everything's pretty normal. But once you put down an object that can roll, it will do that in the opposite direction than it should. Local authorities were quick to get the idea and put a signpost directing curious tourists to the mysterious road. Golden Rock, Burma. If you happen to be in Burma, these days it's also called Myanmar, make sure to visit this well-known site. A gold leaf-covered boulder sits upon the edge of a cliff, and a small pagoda is built on top of it. The impressive thing about the rock is that it only lightly touches the cliff for support. In fact, it looks like the boulder will fall any minute now, but it has been standing like that for centuries. On top of that, the pagoda built upon it is not really a recent addition, so it's quite an unusual sight to see. The rock seems to be saying, "Gravity? I don't care about that stuff." The legend has it that what keeps the boulder in place is a single strand of Buddha's hair. Well, I don't know about that, but you can check out the rock for yourself and see that it's not attached to the cliff by anything. And yet, it's not budged for 2,500 years. Something must be at work here, huh? Stone of Damasco, Argentina. If there ever was a thing that said, "I defy gravity" out loud, it's the Stone of Damasco. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately, today you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people in the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. Well, not exactly put it together chip by chip. They made a plastic replica of the rock and put it on the same spot and even in the same position. So even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Devil's Tower in Wyoming, USA. Remember this place from the movie Close Encounters of the Third Kind? If not, you should go watch it, but not right now. This place doesn't make you feel like you're witnessing some magic and doesn't really trick gravity right before your eyes. Sounds almost boring compared with the rest of the sites on my list, right? But the true mind-blowing feature of Devil's Tower is that scientists can't explain how it came to existence in the first place. You see, it's an 867-foot rock formation with walls so steep they're basically vertical. But that isn't even the main thing. This piece of stone just rose amid rolling plains of Wyoming with nothing like it for miles and miles around. So how is it that such a flat landscape could have suddenly given birth to something so tall? Theories abound, but nobody has the answer yet. My theory? Well, perhaps here is where the Earth has a giant outie belly button. Well then, you come up with a better theory. Oregon Vortex, USA. The House of Mystery in Gold Hill, Oregon amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. And there's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in this shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoided approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place and spread the news about it in newspapers and later on the internet, and voila, a perfect anomaly is made. In fact, it's no more than a curiosity, a human-made optical illusion that tricks your eyes and other senses. Hudson Bay, Canada. Okay, we've talked about some pretty ambiguous stuff, but now it's time for the real deal, the Hudson Bay anomaly. This is probably the only place in the world where gravity is indeed lower than anywhere else on the planet. Even skeptics can't smirk at it because the difference has been measured with precision equipment. So, does it mean that the gravity here is as low as, say, on the moon then? Unfortunately, or is it luckily, I'm not sure yet, the difference is minuscule. The exact value is 0.005%, or 1/200%. You won't be able to feel it even if you try your hardest, but it's still there. Scientists say this anomaly exists because of the ice sheet that covered the area about 10,000 years ago. It compressed the rocks so much that they still can't fully recover, shifting the gravitational field in Hudson Bay. Sometime in the future, though, the gravity will return to normal in this area as well. No moonwalk for me then.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project: figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000, from every corner of the states. Not everything was picture perfect, tough. There were 2 main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey. When we were young, we were told that a second was 1/60th of a minute, and there are 3,600 of them in an hour. This information is so deeply rooted in our day-to-day activities that we rarely question it. How do we know how much a second really lasts? Each unit of measurement we use to tell time, like days, hours, and minutes, is connected to how the Earth spins around in space. People in ancient times looked up to the sky and noticed that our planet takes a certain amount of time to do stuff. That was their way to track time, and for the most part, things haven't changed. However, our calendars have gotten a bit more precise these days. You see, our world's a lot more technological now, with computers working extremely fast, being able to do billions of things in a second. We can't rely solely on Earth's movement to measure time. That's because our planet's patterns change a tiny bit over time. Imagine if today's second was slightly longer than yesterday's. It would mess up calendars all over the world and cause trouble for all sorts of devices. So, in the 1950s, scientists thought of a precise way to measure a second. Instead of looking up at the stars, they zoomed in on some of the smallest things available: atoms. They found that certain materials, especially one called cesium, move in a very predictable way. Today, we know how much a second lasts based on the movements of cesium atoms. This way of counting seconds has some ancient ties, though. It's connected to how an astronomer named Simon Newcomb watched the Earth move way back in the 19th century. He tried to understand the exact movement of planets and why they sometimes stray from their regular path. He also studied the moon and its phases and figured out the previous lunar calculations were wrong. When scientists switched to their atomic stopwatch in 1967, they made sure it was in line with his observations. We know that our planet makes a complete rotation on its axis in 24 hours. That's not exactly true. It does it in 23 hours and 56 minutes. We also know that for Earth to rotate around the Sun, it needs 365 days. That's not entirely accurate either. In fact, it needs an extra 5 hours to finish the task. That's why every 4 years, we add an additional day to our calendars during the month of February. By using cesium to measure the exact duration of a second, we make sure we're always consistent. This type of metal is used today in most atomic clocks. You'll find them everywhere. They're in the gadgets that need GPS in our cars and phones, in those huge networks that let us call or text each other, and of course, in science labs doing all sorts of research. And here's how the atomic clocks using cesium actually work. Each device has this special chamber. Scientists call it the microwave cavity, but they don't use it to reheat leftovers. It's also full of cesium fog. When they pump microwaves into this chamber, it's like turning on their favorite playlist for cesium atoms. They start moving around and they emit radiation in a special way and for a specific amount of time. This tune then gets caught by a sort of atomic ear, or a detector if you want to keep it technical. It's matched with a known beat to see if they're in sync. If there's any difference between these beats, the clock tweaks itself, the same way singers adjust the pitch of a song to match another. Not all atomic clocks use cesium, though. Some use other metals too, like rubidium and strontium. Some even use hydrogen. But the principle is the same. They monitor atoms to tell time. Regardless of the materials they use, atomic clocks are certainly more precise. But they aren't 100% accurate either. In fact, even one of the most accurate atomic clocks in the world, located in Boulder, Colorado, can have errors. However, current estimations say it can have an error of about 1 second in 100 million years of measuring time. Way better than looking at the sky to tell time. Either way, this celestial time-telling is part of our history. Thousands of years ago, our ancestors began using the moon to track time. They drew little pictures of its phases on the walls of their caves and on smaller objects too, like bone fragments. This shows us that people had this need to plan their activities even when they didn't have a watch on their wrists all throughout the day. Fast forward to about 5,000 years ago in Egypt. Locals there saw that a star named Sirius rose at the same time the Nile River flooded. This flood was very important because it helped them grow food. So, people came up with sundials, these big outdoor clocks that could tell time using shadows. They even broke the day into 12-hour chunks, very similar to the system we use today. The Egyptians even made the first water clocks, using the dripping liquid from a tank to show the passing hours. Inspired by this, people in Asia came up with a better way to tell time. They used mercury instead of water because it wouldn't freeze. The hourglass, that beautiful timer with sand inside, came around only about 1,000 years ago. Just like the water clock, it used gravity to measure time. Another fun invention was the candle clock. Imagine telling time by seeing how fast a candle melts. In the 14th century, Europe built its first mechanical clock, a big step toward modern watches. These early gadgets weren't all that accurate, but they kept improving. By the 16th century, thanks to a swinging pendulum, clocks got a lot better at telling us a bit more precisely what time it was. As timekeeping kept evolving, things didn't necessarily go smoothly. At one point, scientists tried to create a universal standard for time. They used a swinging pendulum, but it didn't work the same everywhere on Earth due to gravity. That's because this force can differ depending on where you are on our planet. It also affects everything with a mass, so it obviously messes up pendulums too. We also needed to tell time accurately while at sea. The British, for instance, wanted a durable and precise clock for sea travel. Enter John Harrison, who spent over 30 years perfecting a clock that could withstand the challenges of sea voyages. It's called the marine chronometer, and it helped with better calculating one's position at sea. This was an important step in the field of navigation, but it still relied on watching celestial bodies. Regardless, thanks to inventors like Harrison, timekeeping kept getting better and smaller. What started as huge metal devices eventually became pocket-sized. These days, we have ways to tell the time everywhere, like on our TV sets, watches, phones, and in our cars. But you can always go back to the basics if you've run out of battery, and for some reason, there's no one around to tell you the time. You'll need to be outside, though. Begin by positioning your body towards the sun. Stretch one of your arms in front and make sure your palm is facing you. Then rotate your hand so your fingers are parallel to the horizon. Make sure the fingers are close together and move your hand either up or down so that your pinky is aligned with the horizon. Start counting how many fingers you'll need to reach the sun. You may need to stack fingers from both hands on top of each other until you get there. This all depends on the time of day and possibly even the season you find yourself in. If your fingers are average in thickness, then 4 of them are the equivalent of 1 hour of sunlight. It won't be as precise as an atomic clock, but it does show how resourceful we can be by just looking at the sun, using our hands, and adding just a dash of simple mathematics.
Houston, we've got good news. A group of select humans is being interviewed to hop on board the first commercial vacation to outer space. The space agency has given you a survey to answer. They want to know what you would pack on this space adventure. Depending on your answers, you just might be one of the chosen ones. Now, how about we take a look at that list together? Pencils. I guess I never would have thought of that, but it makes sense. Legend has it that the US spent millions of dollars trying to design a pen that worked in space. You know, since the lack of gravity is a huge, inescapable factor of life in outer space, pens don't work. The ink won't flow down as it does here on Earth. It turns out that pencils will do the trick. This way you can play word puzzles with the other space tourists, or even make some drawings of your adventure. You'd never forget to pack a toothbrush, of course. According to veteran astronauts, toothbrushes are so simple, yet their technology is enough for space. If you were to squeeze a water bottle inside a spacecraft, the molecules of water would float around in small bubbles. But if you wet your toothbrush, it naturally holds the water in it, keeping it moist to receive your toothpaste. Oh, I was going to say funny socks. Glad that you beat me to it. Here are 2 things. First, there's not a lot of walking that goes on in space. People don't tend to touch the ground too much up there. And second, space isn't the best place to showcase your fashion style. Yeah! Astronauts tend to use special clothes while they're out there. And it will be no different for you as a space vacationer. So socks will keep your feet warm and fuzzy, but they'll also speak for your fashion interest. Maybe one day you'll wear a smiley face sock, while the other day you'll go for a Grinch-themed one. Of course, socks are pretty helpful on board an aircraft. They'll make you slide through stuff more easily. Next time I go to the convenience store, I'll remember to buy some wet wipes for your space travel. Experienced space travelers do love them. And it wasn't even NASA that invented them, huh? Since water is a no-go inside a spaceship, the best option is wet wipes. Better yet if they're scented. Astronauts even use different kinds of wipes. They buy the disinfecting ones and the ones to use on their bodies. Just make sure you know how to tell the difference between them when you're up there. There's a popular myth that says that NASA invented Velcro. But the truth is, we tend to think that everything that's used in space was invented by NASA for a very intelligent and specific purpose. It wasn't, though. Velcro was invented for mundane reasons back in the 1950s by a Swiss company. They were adopted by space travelers because they work as anti-gravity props. They don't erase gravity, of course, But you can glue Velcros into daily stuff, and then hang them on the Velcro attached to the spaceship's walls. It's a very smart system, but best to take your own pair, right? If you're spending a long time in outer space, photographs from back home might come in handy. Choose them well, though. Since the spacecraft isn't all that big, the rest of the people on board will know which pictures you decided to bring along. Best to keep that Harry Styles poster back in your earthly bedroom, right? Just bring real pictures of people that you know and love. Did I hear pizza? A huge part of traveling and exploring new places is being able to taste different flavors of food. In outer space, that's a bit more complicated. But hey, at least you can take some pizza with you. Well, actually, you'd have to have it delivered to you in a cargo ship. This way, ingredients would come fresh and ready to eat. It wouldn't be the first time that people in space tried eating Earthling junk food. Some astronauts have even eaten crepes and hot dogs. Perhaps the best part of this pizza party would be that your food could float. Now, isn't this a super nice way to enjoy some Earth delicacies? As much as I understand your desire to pack a toilet with you on this space trip, that's virtually impossible. I mean, I understand you. Some people are attached to the toilets in their homes, and a space toilet is far from the ideal experience. But NASA has been improving their toilet system, and it's the best it's been over the years. So that will have to do. Here's something I would take as well. A laptop. But what good would it do in outer space, you might ask? Apparently, there is internet all over the International Space Station. So even if you're not spending most of your trip docked at the ISS, you could enjoy some Netflix on the days you spend over there. There is internet all over the ISS, apparently. Crazy, huh? And speaking of leisure, I love that you would take a yo-yo. I'm not sure how efficient it would be in space, since there's no gravity to bounce it back and forth, but it would be nice to see how a yo-yo reacts in a gravity-free environment. Oh, I love jigsaw puzzles. This would definitely be on my list as well. Imagine trying to build a jigsaw puzzle that keeps floating in the air. Maybe you'll have to create a system to avoid the separate pieces floating aimlessly through the spacecraft. But imagine once you finish that turtle puzzle, it will look like it's swimming around the craft. You can't pack a window, but they sure are an important part of life in outer space. Let's keep in mind some of the rules of the trip. Each traveler will have the opportunity to do one spacewalk during their time in space. This is already huge. Consider yourself lucky. Some elite astronauts only get to do one spacewalk during their entire career. That is so because spacewalks are risky and require a lot of training. But you'll get your training once you're up there. The thing is, all other days you'll be stuck inside a floating tin can. So windows will come a long way. They'll help to remind you where you are. They'll give you some perspective of space and Earth. Of course, you should take your camera. How else will you be able to register for this once-in-a-lifetime experience? Just make sure it works inside an aircraft or the ISS and you're good to go. Coffee? Don't worry, you don't need to pack your own. Up until recently, astronauts had to rely solely on instantly brewed cups of coffee when they were in space. But you're lucky that coffee experts have already solved this issue. Nowadays, there's the IS espresso machine. The machine itself is similar in size to an Earthling espresso machine. But to drink it, space travelers have to use a zero-gravity coffee cup together with a straw. If you try drinking it regularly, you wouldn't get hot coffee to hit you directly in your face. Instead, the coffee would be glued to the bottom of your cup. I have to say I really stand this invention. Last, but not least, why not pack your guitar with you? I noticed you were missing a musical instrument. If this was a conventional flight, you might have to pay extra for luggage. But since it's all included, don't be shy and take your guitar. Astronauts such as Chris Hadfield take their musical instruments with them when they're in space. He even became famous for his version of Bowie's Space Oddity, up to the point that Bowie himself told him he lived Chris's version of it. It helps to pass the time, but it's also great for socializing. Can you imagine a pretend bonfire happening in the void of space? I can, and it looks super cool. Well, I think you're set to go. I'll personally call NASA and ask them to pick you as one of the lucky space travelers. See you in outer space, amigo. Your kitchen sink is filled with dirty water. You've just washed the dishes, and you pull the plug out of the drain hole. Do you see how the water forms a funnel, and all the pieces of food get into its center? This is a small whirlpool. Now imagine that this is not a kitchen sink, but a sea with a several feet wide whirlpool. And it draws in not pieces of food, but a small boat. And you're on this boat. You jump off the side and try to swim away. But the whirlpool is stronger than you, it attracts you despite your attempts to swim away. So the first thing you should do is calm down. Yeah, it isn't easy when the deep sea is trying to swallow you up. But if you don't save your strength, you won't be able to survive. And now remember one life hack. Do not try to swim in the opposite direction when the current from the shore carries you away. Head to the side. Thus, you escape from the stream sooner or later and can safely swim to the beach. Inside the whirlpool, you have to act similarly. You need to stop struggle and swim in the direction of the flow. Thus, you'll keep your energy and increase your speed. But don't swim at the very center of the vortex. Try to move away from it in the last moment and you'll get out. Now go to the surface and stay away from the whirlpool. Great! You have survived. You promise yourself never to go to sea again without a life jacket. But of course, the best way to escape from the whirlpool is not to get caught. If you're going on a sea cruise or kayaking at the mouth of the river, find out all about these places. Perhaps they are filled with water traps. You swim to the shore and decide to learn all about whirlpools. It forms in the sink or bathtub because the water begins to drain into the hole and swirl. There are no drain holes in the sea, lake, river, or ocean, and water is formed there because of the collision of two currents. A strong wind can only create one current. The difference in water temperature and its density can make another. Also, the current can be caused by tides. This is when the moon's gravity affects the water. So when two currents flowing in different directions meet, they form a vortex. Two streams of water swirl around each other and move down in a spiral, creating an empty space in the center. Most of the whirlpools are too small and don't pose a danger. But if the water vortex is strong and large, it can sink ships. Such strong whirlpools are called maelstroms. They are usually formed when two currents collide near narrow reservoirs and straits. The world's largest and most dangerous maelstrom is located in the Saltstraumen Strait in northern Norway. Every 6 hours, a whirlpool forms there with a diameter of about 33 feet wide and 16 feet deep. And it can be several whirlpools formed at once. Ships sailing through the bay follow a strict schedule to avoid falling into the water trap. This whirlpool got into the Guinness Book of Records as the largest in the world. However, some whirlpools are hundreds of times bigger, but they are invisible. Giant whirlpools in the Arctic Ocean can reach 18 miles in length. This is the size of a city, and these giant whirlpools are invisible. Fortunately, they are not as dangerous as those that form in Norway. The waters of the Arctic and Atlantic Oceans mix and form water vortexes invisible to satellites. Usually scientists notice such whirlpools with the help of thermal imagers or a change in the color of the water. When the current filled with marine life mixes with lifeless waters, it is visible from the satellite. But the new giant whirlpools are masked under a layer of water with the same temperature. They hide deep enough not to be noticed by satellite thermal imagers. Scientists manage to catch them using gliders. These small pilotless submarines float underwater and record information about the temperature and salt level. Scientists discovered that these whirlpools formed because of the collision of cold and warm currents. Warm water here is rich in nutrients, while cold water is almost lifeless. In this way, warm currents share useful elements and spread them evenly throughout this region of the ocean. Observing invisible whirlpools can help scientists uncover many details about the structure of ocean ecosystems. Whirlpools exist not only in water but also in space. Vortexes from the plasma energy of the sun can be several times wider than the radius of our planet. However, all this solar radiation cannot create giant vortexes on Earth because the magnetic field protects us. The solar wind glides past the planet's atmosphere like a wind over the ocean's surface. But a little energy still manages to break through the protection. Solar whirlpools insert an electrified gas into the magnetic field, creating holes through which the sun's plasma passes through the atmosphere. If whirlpools happen during the collision of different currents, it means that you can predict their appearance in advance. But there are unpredictable natural phenomena in the seas and oceans that pose a danger for small boats, yachts, giant ships, and oil rigs. The phenomenon is called a rogue wave. So now let's get aboard your yacht and sail somewhere in the ocean. It doesn't matter what ocean and where exactly you are, because rogue waves can appear anywhere. A small storm is starting, but your boat can easily handle it. The wind raises small waves that beat against the hull of your yacht. But then, among these waves, one giant appears several times larger than all the others. It would quickly turn your vessel over like a paper ship. But fortunately, this wave passes by and dissolves into the sea. This unpredictable wave of enormous power can destroy huge ships in a second, and such disasters have happened many times. Sailors all over the world told each other stories about the giant waves that appear during a storm and in a quiet sea. Many considered such waves only fairy tales, such as legends about the Kraken and Atlantis. But at the end of the 20th century, people were able to capture this sea phenomenon with a laser detector that measured the size of the wave. On January 1st, 1995, a massive rogue wave crashed into an oil station in the Norwegian North Sea. There was a storm that day, with big waves about 40 feet long. At some point, they formed a big guy, an 85-foot wave. That day, rogue waves turned from a fairy tale into reality. Researchers estimated that this natural phenomenon may destroyed about 22 supercarriers only in the second half of the 20th century. Also, scientists discovered that just 1 in 10,000 waves is a rogue one, and every year, their height increases by 1%. Some of the largest rogue waves reached a height of 100 feet. It's like a 10-story building. This giant can easily break even the strongest and largest ship. Scientists can't always predict their appearance, and still don't know their nature, so rogue waves make the ocean a much more dangerous place than we thought. According to one version, rogue waves appear because strong winds create big waves. When two such waves collide with each other, a giant rogue wave may appear. Another theory says that eddies create rogue waves. These eddies form along the edges of the ocean currents, and then they drift separately for a long time, increasing kinetic energy and forming eddies field. The kinetic energy contained in these fields can charge the waves and increase their strength. However, scientists study microwaves and light to understand this phenomenon better. It turned out that these sea waves are similar in their behavior to these two natural things. The researchers hope studying light waves will help understand the nature of rogue waves.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios. More of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora, or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
Are you a pro swimmer? Brave enough to take a dip in any ocean or sea? Bad news. There are some places you should avoid no matter how well you swim or dive. Some of these places have dangerous underwater rocks, strong currents and tides. Others are famous for legends about monsters and mysterious creatures. So let's dive into this aquatic horror show. Have you ever heard the word the strid? It's a variation of the word the stride that is used in Yorkshire. And it refers to a narrow section of the river wharf that's so small you could jump over it. But don't be fooled by its size, it's one of the most dangerous spots around. Even taking a step into the water can have dire consequences. The river wharf has a forceful current, and since the strid is so narrow, it's even stronger in that area. The intense water flow has eroded the limestone around the strid, which created hollow spaces much deeper than the rest of the riverbed. Here's the secret. The current has also weakened the banks of the strid from below. So, the ground you're standing on, admiring the rapid flow, is probably just a fragile ledge hanging over treacherous waters. There's no record of anyone who found themselves in the water of the strid and found their way out of it. And the worst part? You wouldn't even guess that this innocent-looking stream could be such a danger. So, my advice to you, my friend, is to stick to a safer body of water for your aquatic adventures. If you're looking for a weekend getaway in California, Horseshoe Lake is the spot for you. It's got everything. Sandy beaches, hiking trails, and picnic areas, but wait, there's more to it than meets the eye. This lake has a dark side, namely around 100 acres of dead trees that surround it. And it's not just the trees that have been claimed by this lake. The earthquakes that hit in 1989 and 1990 unleashed carbon dioxide from under the hot magma. The gas seeped out into the air, damaging all the life around the lake. Even now, Horseshoe Lake is just as dangerous as it was 30 years ago. What makes it so scary is that the levels of this toxic gas change randomly. Warning signs that are posted everywhere certainly could give a horror film touch to a fun hike in the woods. In Kauai, Hawaii, there's a group of stunning waterfalls that used to be a popular destination for tourists. Kipu Falls, as they're called, were once the go-to spot for swimming and diving. To get to them, you had to take a long walk along a dirt path until you finally arrived at a breathtaking view of a 20-foot waterfall pouring into a crystal-clear pool below. But since 2011, this area has been off-limits to the public. Why, you ask? Well, there have been a lot of accidents at Kipu Falls. Obviously, jumping off the top of the waterfall would be an obvious reason for that, but in addition, there were much more mysterious cases. Witnesses tell tales of swimmers peacefully enjoying the pool at the bottom of the falls, only to be suddenly dragged under the surface. No definite explanation was found to these accidents. The locals believe that the water spirit Mo'o is to blame because it doesn't appreciate being disturbed by loud tourists. There's also a theory of a powerful whirlpool at the bottom of the pool. In any case, guide publishers do not mention Kipu Falls anymore, and trespassing is severely punished. The Samizan Hole, located in the Gulf of Thailand, is the ultimate spot for thrill-seeking divers, but it's also the most dangerous one. With a drop of 280 feet, it's the deepest diving site in the region. But its depth is not the only reason it is considered a place to avoid. The area is a major shipping zone for giant oil tankers. The strong currents around the hole make diving even more treacherous. And if that's not enough, the Samisen hole is also home to deadly barracudas that could easily attack unsuspecting divers. The water is so murky that visibility is nearly zero, making it challenging to spot these aggressive sea creatures. All in all, the Samisen hole is a breathtaking but extremely hazardous spot that should only be explored by experienced divers with nerves of steel. Let me tell you about New Smyrna Beach, the shark attack capital of the world. If you're looking for a relaxing vacation spot in Volusia County, Florida, you may want to reconsider this beach. The waters around New Smyrna Beach are teeming with fish, which attracts a lot of sharks. In fact, there have been so many shark attacks reported in this area that it's earned the title of the shark attack capital of the world. Even scientists have warned that if you go for a swim there, you're bound to get up close and personal with at least one of these creatures. We are talking about a distance of 10 feet, and in many cases you wouldn't even notice it. To make matters worse, the bull shark, one of the most dangerous and aggressive types of sharks, has been spotted in these waters. Once again, Kauai is on our list. The beach on Nepali coast called Hanakapiai Beach might look like heaven on earth, but don't be fooled. To get there, you have to trek through a super steep, rocky 2-mile trail. There are no lifeguards on this remote beach, so even if you decide to take a dip in the water, you're on your own. The biggest threat to your safety is the incredibly strong rip currents. They are almost always present because there are no reefs to shield the shore. And if someone gets caught in one, there's no safe place to swim to for miles. The nearest safe beach is 6 miles away. Trust me, this beach doesn't have the best track record in terms of safety, so it's highly advised that you stay out of the water if you end up at this beach. Let me tell you about a place that looks like it's straight out of a horror movie. We're talking about Berkeley Pit, which is an artificial lake situated in Butte, Montana. The first thing you'll notice about this place is that it has an eerie blood-red color that can only be described as unsettling. You might be tempted to take a dip, but that would be a grave mistake. Don't even touch it. The water is extremely dangerous due to the heavy metals present in it, such as cadmium, arsenic, zinc, lead, and copper. They come from the rocks that surround the lake and make the water super acidic. In fact, this place used to be an open-pit copper mine, hence its color. So if you want my advice, avoid this place like the plague. There are 3 lakes in Africa that maybe are the most dangerous places of all that I have mentioned so far. They're all located in Africa. Lake Monoun and Lake Nyos in Cameroon and Lake Kivu in Rwanda are all like ticking timers ready to go off. They were formed over underground pools of molten rock, and sometimes this molten rock releases toxic gases like methane and carbon dioxide right into the water. When this happens, the gases can build up until they suddenly burst out of the water, creating massive waves that can wipe out everything in their path. This type of outburst is called a limnic eruption, and it can release a cloud of poisonous gas that can be harmful to everything in the vicinity. The most terrifying part? These explosions can happen at any moment with no warning. So if you ever find yourself near one of these lakes, you'd better be on high alert, because you never know when the next accident might happen. Maybe you know other places you wouldn't recommend for a fun swim? Share your anti-recommendations in the comments below.
Massive tsunamis, destructive tornadoes, giant meteorites, devastating earthquakes. Ooh, better have insurance. But all these are minor natural disasters compared with the eruption of a volcano. Some volcanoes can destroy a city, as it was with Pompeii, or some islands in the Pacific Ocean. But there's a dangerous type of eruption that can destroy all life on the planet. This type is called flood basalt. But first of all, let's figure out what a volcano is. Rivers of hot liquid metals and incandescent rocks flow deep inside our planet. And the deeper it gets, the hotter they are. The source of this hot mass is the mantle, which is the middle layer of Earth, located between the core and the crust. These fiery streams are called magma, and it flows everywhere. But we don't feel its heat because of the thick layer of our planet's crust. Magma is lighter than the crust, so it always tries to break out to the surface. And in some places, it succeeds. At the junctions of tectonic plates, it splashes out when one plate moves under a thicker one. When magma reaches the surface, it becomes lava. This substance burns the ground around and cools down quickly. It hardens and forms a new layer of rock. The following splash of magma falls on the top of this layer. Thus, a mountain appears layer by layer over millions of years. And in its mouth, a fault of tectonic plates splashes out magma. This mountain is called a volcano. It spits lava and ash into the sky, then falls asleep and wakes up again during seismic activity. Now imagine that several giant volcanoes begin to splash out an infinite amount of magma. It just doesn't end and covers an entire continent. This is a flood basalt, and one day it did happen. About 252 million years ago, in the northern part of our planet, a lot of magma accumulated under Earth's crust. Trillions of tons of hot rock were concentrated in one place on a gigantic territory. And gradually, all this fiery energy began to seep out of the ground. Hot gas started to come out in different places in this territory. The ground shook endlessly, and the crust rose hundreds of feet, all pointing to the approach of an imminent catastrophe. And then, at some point, magma began to pour out. Giant fountains of fire burst out of the ground. Do you know these geysers in Iceland? So imagine the same things, but dozens of times higher and with hot lava and ash instead of water and steam. The ash and lava flows were so strong that they reached the clouds. Under Earth's crust, there was a gigantic bubble of magma, and it squeezed out fiery jets under the pressure of rock and ground. The rift was getting bigger. Magma was flowing out everywhere. It began to fill the entire North Continent. The flood of lava spread wider and wider. The streams of molten rock seemed endless. Layers of molten basalt rock overlapped one another, forming a giant tsunami of lava 160 feet high. It poured out of the ground for hundreds of thousands of years, flooding forests, rivers, lakes, and meadows. At the same time, billions of tons of volcanic ash rose into the sky, which could lead to a volcanic winter, since sulfur dioxide in the ash reflected the sun's rays. This might have lowered the temperature on the continent by several degrees. Then, dust and ash probably condensed and formed giant clouds that watered the surface with toxic acid rain. But after that, the cooled lava formed a giant thick shield, preventing magma from seeping out of the endless fire bubble. The global catastrophe was over, but only for a short time. Trillions of tons of magma were still flowing under a thick layer of solid basalt. The fiery rivers couldn't reach the top, so they spread out to the sides. As a result of this expansion, huge nets were formed under the thick rock. They ran in different directions like a spider web and heated Earth's crust. Gases started coming out from under the surface again. More and more energy accumulated there until an explosion of unimaginable force occurred. In addition to magma, carbon dioxide and ash escaped to the surface. They filled the atmosphere and caused the greenhouse effect. The temperature on the whole planet increased by several degrees. This release provoked another catastrophe that began in the ocean. There were deposits of methane, an explosive gas, on the seabed. Under ice-cold water, the methane was frozen and harmless. But the greenhouse effect in the atmosphere warmed up the entire ocean. Millions of tons of methane began to rise to the surface. This gas is more potent than carbon dioxide. Therefore, when it hit the atmosphere, the temperatures on Earth increased again. The whole globe turned into a hot sauna. In previous cool and humid places, the temperature reached those of a modern Sahara. Of course, most animals and insects couldn't survive such a cataclysm, but ocean life took much more damage. The heat and methane reduced the amount of oxygen in the ocean. Fish and other marine life couldn't survive in such conditions. New problems appeared when anaerobic bacteria started to multiply in non-oxygen water. They fed on methane and carbon dioxide and released hydrogen sulfide, a toxic substance that poisoned water even more. About 75% of land animals and 95% of the ocean's inhabitants went extinct. This flood basalt eruption was the only disaster in the planet's history that destroyed almost all plants and significantly reduced the insect population. Several species of the hardiest animals managed to survive in these conditions. The planet took about 10 million years to recover completely. After that, evolution began a new process of developing life. And here are two pieces of news. The bad one is that flood basalt will happen again and will be no less devastating than 252 million years ago. The good news is that it will happen in hundreds of millions of years. But when that happens, humanity will need to be prepared. It will start on the ocean floor. First, lava fountains miles high will begin boiling the water and emit sulfur dioxide into the atmosphere, where it will reflect sunlight. Along with ash and magma, a massive amount of water vapor will rise into the air. Livestock won't survive, and people will have breathing problems. Acid rain and increased humidity caused by the evaporation of the oceans will lead to the corrosion of buildings. All flights will be canceled. People will have to wear gas masks. Many animals won't be able to handle this eruption, but humans will adapt quickly. But then another and another eruption will follow, and this endless catastrophe will soon deplete the resources of humanity. Plants and trees won't recover so fast, and oxygen production will be significantly reduced. Let's hope that humanity will have colonized other planets, including those outside the solar system by that time. And now, let's jump back to the present. About 70% of the seismic activity associated with volcanoes occurs underwater. So let's see how ordinary volcanoes on the ocean floor work. Water, as well as land, rests on tectonic plates. Therefore, if their structure is broken at the joints, magma seeps through them. But unlike terrestrial volcanoes, lava here doesn't spread in different directions, burning everything it meets. It solidifies under the pressure of cold water. Underwater volcanoes can erupt for a long time with breaks in between. Magma covers the seabed. After another 100 or 1,000 years, a new eruption begins and a new layer of rock forms over the previous one. Over millions of years, layer by layer, magma is rising. And then, one day, a volcano rises out of the water. Magma splashes out of it and increases its height. And now we have a large volcanic island. Then the volcano falls asleep and life appears on the newly formed piece of land. Magma flows from the planet's mantle, filled with various chemical elements. This hot mix saturates the soil with useful substances and thus promotes the growth of plants and trees. Then birds and other animals arrive there, and the volcanic island turns into a paradise. Then humans arrive and pave over paradise to put up a parking lot and a franchise burger joint.
You've been training for this for years. You know you're ready. You're standing on the door's threshold. You take a deep breath and bravely open it. You jump outside the International Space Station and into the vastness of space. This never gets old, you say on the transmitter device. You feel like a feather whenever moving through space. Except for the suit, of course. It's true what that guy told you one day. Astronaut suits limit your body's movement by 20%. For you, that means you've got a 20% higher chance of being clumsy in outer space, which is never good odds. There's not a lot of room for error during a spacewalk. You finally get to the docking port. You look around and see the part of the station that needs fixing. This is where other space shuttles dock when they come in from Earth or other planets. About a week ago, a shuttle coming from Jupiter miscalculated the landing and broke a piece of the port. You've attached the new shield to your suit's belt. Now all you've got to do is screw it on the station. You've spent hours training underwater to do this. You wore a heavy, hot, uncomfortable suit inside a pool in order to get the training you needed. Incoming! Sarah shouts on the transmitter. You don't even have time to ask what, as an absurdly fast storm of space debris catches you off guard. It shakes everything around you. You try to hold on tight to the strap that's keeping you safe, but oh no! A piece of debris just hit your helmet shield. "Come in, Bob, are you okay?" Sarah asks you through the radio. You got a bit shocked by the impact, but everything seems fine. The meteorites are finally gone, so you can focus on your task now. You pull the rope that's connecting the new docking shield closer to your body, but the other part of the rope has nothing on it. Zip. Nada. Oh my, you think to yourself. Come in, Sarah, we have a lost shield. I repeat, we have a lost shield. This is a pretty serious situation, and you are aware of it. Anything that falls into space can go into a collision route with the International Space Station or with other space vehicles. You try to remember your training, but your mind goes blank. This is worse than that one time you broke your girlfriend's favorite ceramic jar. Sarah, the other astronaut who's with you on the ship, is shouting words on the transmitter. "Oh no, Bob. Tell me you didn't do this. This is a total catastrophe. I'm coming outside." You spot the shield under the ISS. It's the size of a medium-sized car door, and it's moving quite fast. Here's what can happen in this scenario. The shield could head back down to Earth and break into the atmosphere. It would probably catch fire and disintegrate on the way down, but anyways, it would make NASA and you look pretty bad. The other option is the car door-sized shield gains momentum, and it orbits all the way to hit the ISS, and you for that matter, or some satellite that happens to be in a similar orbit. Here's the thing. If you ever thought that space was an infinite void, you got that part wrong. Since different countries started to build equipment strong enough to travel in space, space has been more crowded than ever. Not with people, but with satellites, asteroids, and space debris. You were surprised when you learned that Earth receives meteorite showers every single day, but they're so small that no one on the surface of the planet notices it. They usually turn to ashes before hitting the ground, but that's not all. What just happened to you on this mission has happened on several other missions before. Astronauts keep losing stuff in outer space. So much so that NASA had to create a division to track down and monitor the orbit of all debris that is just floating carelessly around. You couldn't believe it when someone told you that there are over 23,000 softball-sized pieces of debris roaming around in space, and if we're talking about smaller objects, then that number goes up to 500,000. As you were about to unstrap yourself and dangerously venture through outer space without any protection, you notice Sarah has beat you to it. You can't let her do this alone, so you decide to tag along. FYI, this is against every NASA handbook and training you ever received in your life. But you think, if this works in sci-fi movies, it must work for us. Even though we all know that's very far from the truth. Sarah's close to the debris shield, but her body weight makes her orbit in a completely different direction. Okay, you think to yourself, this is your turn to shine and be a hero. You try moving your arms like you would do underwater, but there's no friction in space. Duh. You can't butterfly swim your way to rescue the rogue equipment. You try to contact Sarah, but she doesn't come in. I guess you're on your own now. For some reason, you start to orbit in a similar route as the floating car door shield. It must be the amount of stuff you've got strapped onto yourself. Or maybe it was the breakfast burrito you had that morning. You feel like you're George Clooney in the movie Gravity. No, better yet, you feel like Obi-Wan Kenobi. Yes, you're feeling as strong and powerful as a Jedi right now. You keep your hands stretched before your body, hoping you'll gently collide with the space debris. And 3, 2, 1, and the landing was successful. Just joking, but yes, you managed to dock onto the debris. Hooray. Now what? You think? Guess you needed to have gone through that plan of yours a little bit more, huh? You still have no way of steering the debris. And now, you have no way to contact Mission Control and tell them the object, and yourself, are en route to somewhere. Don't get scared. You didn't come this far to get scared. What's the best thing you can do? First, take a mental picture of the Earth. It never disappoints from up here. Then, you try to play out the possible scenarios that could happen in the situationship you're in. Your normal body weight would not be enough to get you out of Earth's orbit. In the hypothetical scenario in which this did happen, you'd probably be vacuumed into Venus's orbit and spend a quite unpleasant period of your life around immense heat. Even though in Greek mythology, Venus represents love, there is nothing lovely about orbiting close to this planet, and you know this. If you got too close, your spacesuit would never be able to take on the heat. It's only made to sustain temperatures of around 250 degrees Fahrenheit tops, and Venus's atmosphere can heat up to 700 degrees Fahrenheit. But honestly, the worst-case scenario is much simpler than that. Your spacesuit could decide to drown your ears, nose, and mouth in water. Yup, this has happened on spacewalks before yours. You see, in order to keep your spacesuit chill and cool, the suit relies on a gallon's worth of water that makes up for a cooling system. This system, which is supposed to send recycled air into the back of your helmet, does leak sometimes. And since you're stranded in the middle of the big nowhere, you'd have only that nowhere to run. But wait, what's that popping up on the horizon? It's a modular space shuttle. You try shouting, but nobody can hear you outside your helmet. You wave with your hands, but it's coming straight at you. Finally, it took longer than I wished to find you, Sarah said. Apparently, she made it back to the space station just in time to catch you before you went definitely rogue. Guess I'll be losing some astronaut points for this little misadventure, huh? You say. And yes, you definitely will.